Welcome, students, to chapter number 2 in most textbooks, which is also better known as Chemistry, Matter, and Life, or Basic Chemistry. So I'll start off by saying that if you absolutely love chemistry, I want to disappoint you due to the fact that I'm not going to get deep into chemistry. Okay, we're going to stick it to the simple human body, okay, the simple things we need to know. If you don't like chemistry, then you're like, yay! Okay, so got to bring Manee in. He's got to help us. There's Manee. Now, you're definitely going to see within this video, you're going to see the use of me talking about using things within your life, okay, or using things that you can buy at the store to help you to learn. Okay, now those things will be, and it's around that time of year, they got different flavors, are Nerds gummies, okay, and just Nerds are also good, okay, so I feel like I'm promoting the Nerds products, but they do really good at helping you kind of visualize and to be thinking about what these different little pieces that bring us together to make up the human body. So the last video we talked about the part of the organization of the body, from the simplest to the most complex. So we're starting with the simplest within this chapter with chemistry, of talking about a whole bunch of chemicals that we got to talk about that will come together into the next video to make a cell. Okay, that is very, very important. So now I want to keep it kind of simple, okay? Now, most textbooks get kind of advanced with it. This is one of these chapters that I definitely would tell you in most anatomy and physiology training, is that don't get too deep into it, okay? And this is not a chemistry class by any means. When we talk about atoms and stuff, not testing on the atoms, definitely important to understand that, okay? But in a true chemistry class, you'd also need to be able to understand like the periodic table and things like that. Now, start off with some key words, okay? So the first key word is a word of matter, okay? Now, matter matters, okay? So matter is anything, whether it be Manee, me, anything that what they say occupies space and weight. Now, matter can exist in 3 different states, okay? It could be in a solid, okay, such as Manee. It could be in a liquid state, such as water, and it can also be in a gas state, okay, itself. Now, it takes a change in order to change those, okay? I know that sounds kind of weird saying a change makes a change, but it's true. It can be a physical change, such as for us, like chewing food and eating it, and that would be a physical change of all those chemicals we have, or it could be a chemical change. And a lot of what we're going to be talking about throughout this series is chemically based, okay? Meaning that we're adding chemicals to break things down, such as enzymes that are going to assist in that process. Now, the next word besides matter is elements, okay, or an element. An element is a composed, it's matter, okay, anything that can make space and has a weight to it, is composed of atoms, okay. Now, those atoms have the same nuclei, okay, far as positive charges, okay. So, kind of with that, let's think about what an atom is. Okay, so kind of fast forward just a little bit, and again, atoms are something that'd be more in a true chemistry class, but still need to know what an atom is. An atom is the smallest unit within that element. So you kind of take the Nerds candy, okay, and if you were to take one of those little pieces off, those individual little Nerds, off of that big, giant gummy, which is so delicious, they're addictive, by the way, that would be an atom, okay? So it's these small little tiny pieces. Now, those subparticles, okay, or they call them subatomic particles, can either be positive, negative, or think of protons, neutrons, electrons, okay, or have no negative charge, okay? That will kind of make a difference when we talk about some of these elements, aka ions. Sometimes they're also called, they could be called minerals. So you're going to see there's lots of names that you can give to elements that are going to be a positive charge or a negative charge. Okay, so again, kind of knowing a little bit about, again, I'm not getting into where they line up, but do know, again, we talk about the bonds that happens within our human body. These chemical bonds, that's just an attraction between those atoms. Okay, now the 3 types of chemical bonds within the body are the ionic, okay, we're going to focus on that one, the covalent, and hydrogen. Okay, so those are the 3 different types of bonds that are chemical bonds within the body. Now, when we think about elements, there are going to be 4 main types of elements that you definitely need to know. Okay, so 96, almost all of the human body you're going to see is going to have these 4 main elements. All right, so we're going to use the example here within the body. There's 4 main elements. You can see I've got 4 different cups. I've got my main human body, okay, and then I've got some liquid that we're going to add. So within the body, we've got 4 main things. Okay, we got more oxygen. The second one, carbon, lesser. Third one, hydrogen, which I need to switch those because I have my carbon and my hydrogen. And then the last little bit that we're going to have is going to be, let's fill them up a little bit more. My little shot glasses, that being the most, kind of even them out a little bit there. Oops, I had too much of that. All right. So, the most we have, my cup, oxygen. Carbon comes next. Hydrogen. And nitrogen. I can only have so much within this cup. Now, kind of going back to an example you'll see within the pH, to kind of take some of this liquid out of here, back out of my cup, that if I have more, and I should have about the third highest, if I have a lot more, this would be my hydrogen. See how much that is. That leaves less room for then my oxygen. So definitely be thinking about, as we're talking about pH, okay, you're going to see pH coming up within this video, as if I have too much hydrogen, I don't have enough room for as much oxygen as that I need. So think about those 4 different types of elements. So hopefully that little diagram I kind of showed you, or I should say, not necessarily a diagram, but a helper of the different liquids is very important. Okay, so definitely think about that whole glass as us of oxygen is more of it, carbon is next, hydrogen and nitrogen. Okay, that's very important, especially at that end of the chapter is going to be important that you're going to see with the pH. Okay, so definitely I'm going to really mention it then. I'll go ahead and mention it now. Though if we have more hydrogen, that means technically we have less oxygen, and think about what that could do to the body. Okay, itself. So oxygen, carbon, hydrogen, nitrogen. Okay, those are the 4 main elements that make up most of our body. Now, know the symbols. I'm not getting too far off in the periodic table, but definitely know oxygen O, carbon C, hydrogen H, nitrogen N. Okay, calcium is the weird one because like the C was already taken, so they had to add an A. So calcium is Ca. Phosphate would be P. Potassium would be K. Sulfur is S. Sodium is Na. That's a weird one. You definitely want to know that one. And iron is Fe. And know what they do. So go ahead and start learning and understanding that all of these elements that we also are going to know as ions, I'll talk about ions here in a second, also could be known as minerals. Okay, so a lot of different names for the exact same thing, I know, but definitely know what they do. Okay, such as oxygen, we know. Think about oxygen. We need to metabolize these nutrients for energy, but it's part of water. Okay, H2O, the O, of course, hydrogen and oxygen. Okay, itself. So that kind of comes back to, you can kind of see these individual little nerds pieces coming together. Now, kind of with that, most textbooks, the reason why I use the nerd gummies is they have kind of a picture of sodium chloride, okay, all together, and then they show what happens when it electrolytes, okay. Now, electrolyte, okay, this whole piece breaks apart in a solution. So if I was to place this in water long enough, all those little pieces would dissolve into, obviously, a microscopic level where you're not going to be able to see it. So it's said then that the electrolyte is said to dissolve or disassociate or ionize. So that word, okay, disassociate means dissolve. And that's important, guys. So when you think about nitrogen and You think about sodium and chloride, whatever, okay, element that you're talking about. It breaks down then into individual pieces, such as when we consume something. Yes, we have a physically change if we chew it, but if I was just to swallow this whole, it's going to get into what my body is mostly made out of, water. Okay, we'll get to that. Because you think about if most of the body is made then of oxygen, we really need it. Think about H2O, so you can kind of see even the oxygen we have has the same type of element within water. Okay, so H2O, well, you can see why. Okay, and the importance of why most of our body. So when we eat things, get it in our body, we swallow it whole or chew it, then you can kind of see it's going to separate, and then our body is going to, which you'll see within the next video, either allow that part, okay, let's say sodium, to come in the cell or go back out the cell, okay, in this fluid, this river that runs throughout our body. So again, atoms, again, are just the microscopic little tiny pieces within those elements, okay, so again, microscopic. And atoms, or a group of atoms that carry an electrical charge, okay, either positive would be cations, and then anions are going to be the negative. Okay, so in your books, you're definitely going to see, again, using the symbol, knowing the name, and knowing what it does is vital. Okay, sodium, calcium, iron, hydrogen, potassium. We get into like chlorides and bicarbonates and phosphates. Definitely need to know what those individual little pieces, okay, that are made of smaller pieces are doing either positively in the body or negative. And think about batteries and magnets, how they bring something closer, attract it, or repulse it. Okay, or say, no, stay away from me, okay, itself. But they have, main areas that they like to live in. Examples of that is sodium, okay, salt, when we think about that. But sodium itself is a balancer of fluids we're eventually going to get to. But it helps, it's the main one that's outside of the cell, okay. So if you think about that cell, okay, it's going to be mostly liked when it gets in the body, it likes to stay in the fluid outside the cell. So sodium is what they call the chief, meaning main, extracellular cation. It's a positive one, okay, itself. Well, another one that we kind of think about on the outside, we're thinking about sodium. Well, there has to be a main one on the inside of a cell, and that chief main intracellular cation, a positive one, is going to be potassium. Okay, so again, we think about positive and negative, again, either attracting or repulsing each other. Okay, so those are where they like to go as far as high numbers, even though they can be anywhere within the cell. Now, another one that likes to live on the outside would be chloride. Okay, so usually where we see sodium, we're going to see chloride. And to kind of with that, I'll go ahead and mention it now because it will make a difference. Where we find sodium, water, which is the most abundant in the body, is going to chase after sodium. So if sodium goes outside the cell, guess what's following it? Water. So it's like a cat and mouse game, okay? With the mouse being sodium and chloride a lot of times. Water is going to be that cat chasing it. Okay, so it will definitely be important into future classes. We think about, okay, if I am excreting, getting rid of sodium out of my body, also a lot of water is following that. And you can, of course, then think about some of the conditions such as like dehydration, and also another one would be, of course, you think about if I have edema, okay, swelling within the body. Now, also other things in this chapter you're going to see besides that would be some other names. Okay, you notice a kind of a lot of that. Oh, I got to know what this word is. I got to know what it does. Okay, molecules and compounds. Okay, so molecules are just when we take two of those atoms, okay, that are bonded together that are the same. So definitely think about, oxygen. Oxygen comes together, that makes one molecule of oxygen. But compounds are when you take two different, okay, so it's like in this, it has different colors, okay, so like when I'm taking a whole bunch of different types of atoms and putting them together, such as water, oxygen into hydrogens, H2O, okay, that's a compound. So the only difference between a molecule and a compound is molecules are the same thing, compounds are two different types, okay, so hydrogen, oxygen, whatever elements that we're kind of talking about. Now, water with that's the most abundant, again, compound that we're going to find. It also is a molecule because you think about it as H2O. It's very critically useful. We have to have it within our body because things dissolve. Okay, it's called a solvent for a reason. Okay, it's universal, meaning that all these different things we eat and consume, and these ions and electrolytes and elements, all these weird words we're learning about, that's needed in the body for things to dissolve into. But it also is very stable. Okay, we kind of think about, if you're back to chemistry class, mixing the wrong chemicals too much or too little causes, instability. Well, water is very stable, meaning that's why it's very good in the body. But every single body chemical reaction that we're going to talk about is going to need water either in the cell or outside of the cell for that to happen. So the back end of most chemical chapters, okay, or chemistry, and especially in this book, we're going to talk about the last thing of pH. Okay, so pH in the body is what they call, now it's kind of a German for the P, but I'll just go ahead and kind of shorten it and call it the power of hydrogen. Okay, so anytime you see P and H, you notice the P is small and the H is large. That H is always referring to hydrogen. Okay, remember one of the four that we talked about. So if the third one, okay, is higher, okay, I have more of it, then I want to have less of the other ones, especially my oxygen one. Okay, but if I have a lower amount of hydrogen, then I could have more oxygen. That sounds good, but that could be bad. Okay, we need a balance because remember in the first video, homeostasis, we need to keep a balance itself. So an acid and a base. Okay, so acid is everything we're eating has somewhat of an acid in it. It's something that dissociates or splits into more hydrogen. Okay, so think about that. So if I'm eating things and that breaks apart, then all of a sudden, instead of just having one piece of hydrogen, now I've got a lot of hydrogen. So remember, we talked about the numbers going up. Okay, you can see, well, when we're eating things, we think of the acid. Now, a base is a substance that combines with hydrogen during a reaction, but removes that hydrogen, so takes it away. Okay, of course, we'll look at eventually, obviously peeing and pooping it out. Okay, we'll kind of look at that aspect eventually, but it takes out, so it brings that level back down. So base, basic, okay, alkaline, okay, those words all to go together. So base, basic, and alkaline, all three of those go together. And within that, that's where you're definitely going to see. So an acid is me joining in, getting more of my hydrogen, okay. A base is getting rid, and Manee's sad, getting rid of that hydrogen. So if he would be hydrogen. So pH is just a unit of measurement that we measure. Definitely important in healthcare to understand the difference between a 0 to a 14. Okay, so 0's up here. That's a lot of, okay, think about a lot of Manee. Okay, but even like 0, but the 0, the number is low, means I've got the most. When you go down to the bottom of 14, I've taken away that hydrogen. Okay, so 0 to 14 is the number. So remember that as the hydrogen goes up, okay, the pH number is going to go down. Okay, the opposite. So as I go decreasing that hydrogen, the number is going to go higher. So figure out kind of just one side of it and it makes sense, but if you want to learn both sides, you definitely can. So our body's about, again, homeostasis. So the body either neutralizes, okay, or excretes that excess acid within our body. So again, it's a measurement, pH, the definition is important, a measurement of the concentration of hydrogen within that solution. That's important. So it goes from 0 to 14, more of Manee here, less of Manee here. Okay, so 0's up here, 14, or if you do a side to side, 0 being over here, more Manee. Okay, less Manee's over at 14. Okay, now in the middle is water. So know the numbers. Okay, so if I was to throw a number at you, okay, I say 7. 7 is water. Okay, it's neutral. Okay, it's neutral ground, right between 0 and 14 kind of makes sense. Okay, and this is advanced as the math I'm going to get. So blood is a little bit on this side. Okay, so less hydrogen. It's 7.35 to 7.45. But definitely using, every book varies. This textbook I'm using has like listed like stomach secretions of being, about 1.5. Apple juice is about 3. So you can kind of see like coffee, if you love coffee, if you drink a lot of it, eventually what's in your stomach gets into your blood supply. If you get enough of it, then obviously that's going to change your hydrogen levels. Okay, but we want to be Our blood is the measuring factor for our body, so homeostasis for us is 7.35 to 7.45. Now, what happens within that are two different things that we'll really get into future videos, okay, of acidosis and alkalinose. So anything from that 7.35 back to 0, more Manee, okay, we definitely think about those hydrogen levels, okay, so increasing, okay. Now, the other way is alkalinose, okay. So we definitely think about that number of obviously going up, but the hydrogen going down. Okay, so definitely know, start understanding those names, okay, of, high and low hydrogens. Okay, high and low hydrogens. Again, think about the number goes down, the hydrogen goes up, vice versa. Okay, it's definitely important. So again, pH, you definitely need to know your pHs. Okay, so pHs are vital, okay, for you to know. Now, I want to go ahead and talk about now a little bit about, okay, we're thinking about, the hydrogen, the pH levels. Let's think about the things that we eat. Okay, so there's three main things that we consume that, of course, are going to affect our pH levels, but also affects these chemical reactions within our body. So the first one is my favorite, sugar. Okay, so carbohydrates. Manee's like, yes, give me more carbs. Okay, now there are three different types of carbohydrates that we have. We have monosaccharides, disaccharides, and poly. So if you go back to medical terminology and think about mono means one Manee, okay. Di, okay, means two, okay, and then of course poly means multiple manatees, okay. Now mono is the most important because it's the simplest, and that's where we find glucose. Okay, so know some examples. Mono, again, everything we eat's got to go back to monosaccharides, got to go back to glucose, but like disaccharides would be, and examples would be your table sugars. Okay, so every time you eat table sugars, it's going to turn into then two, okay, of those monos. Okay, poly is a lot. So examples would be like potato chips and rice, and when you're consuming that eventually, then you have lots of glucose. Okay, but the simplest is very important. The basic unit of a carbohydrate, it got to go, everything goes back to monosaccharides. So go ahead and start thinking of some examples, especially glucose. Now the second thing we eat is called lipids, fats, cholesterol, okay, oils, okay, it could be a solid. Think of butter, think of bacon, okay. And then when we think about that cholesterol aspect, we definitely think about, of course, you may not think about it now, but we think about steroids, okay. It actually has a ring of carbon within that complex of a cholesterol. Okay, so definitely, think of the high and low numbers. I won't get into it in this video, but definitely get into future videos where we talk about your HDLs, LDLs. But think about if I have too much of something, then there's less room in the body for other things I need. Glucose is very important. We always have to have glucose because it gives us that energy. And then the last of the three things, so we have carbohydrates, lipids, better known as oils, fats. We have to have that, okay. And then proteins is the last one, okay. So proteins, of course, I've mentioned it, before, mentioned it in future videos when we look about proteins. But proteins are these individual little Lego pieces, okay. And I'll kind of bring it back to this. Little nerds, candies that attach and are assembled, but literally everything that we do in our body has to have proteins, okay? It's just a chain of amino acids that are held together by a bond, okay? Like you can think of gummies in some ways, okay? And then that's, of course, going to help with metabolizing, okay? All the things within our body. Now, chemical reactions changes those things, whether it be a carbohydrate, whether it be a lipid, whether it be a protein. And all a chemical reaction is just those atoms, remember those little tiny microscopic pieces that form something new. Okay, so like Na, sodium and chloride coming together, okay, to make, sodium chloride, okay. Again, you would separate those. Think of hydrogen and oxygen, okay. They eventually come together to make water. Now, catalysts and elements. So kind of with that, elements is, again, these individual little, minerals, ions, things like that. But we're eventually going to add in some extra pieces to chemistry, and we're going to use the word a lot of enzymes. All enzymes are proteins that work as what they call a catalyst. Okay, so what is a catalyst? A catalyst is just a chemical that speeds up, okay, the rate that a chemical reaction is going to happen. So in future chapters where I talk about, okay, we're going to have a digestive enzymes, all it's going to do is speed up how the food is broken down to make that chemical reaction to occur. Okay, so our body has lots of liquid, and we're going to talk about just the basic within this chapter. We'll get into future videos where we'll talk about all these other different liquids we're going to throw into the mix. But within this chapter, you definitely got to get the basics, get those elements down, and start understanding ions, so that when we throw in this other stuff, these other elements, okay, technically, but enzymes that are going to change all of those basic parts of how they interact with each other. But within the core part of that cell, you're going to find a thing called a nucleus. Now, nucleus, all it is individual nerds. Okay, that's back to that, the nerds candies, that are arranged, like I kind of mentioned before, with proteins, have to be arranged a certain way. Now, that is also a part of our DNA. Now, our DNA is held within the nucleus. That's where you're definitely going to see that nucleus holds this nucleotide, which is made up of sugar and a phosphate and a base, which makes up our DNA. Okay, so it's again some little tiny pieces that come together, which is crazy to think that literally life itself is made out of sugar. Okay, hence why we probably like sugar. Okay, so again, the arrangement of those different pieces make up our DNA, and we'll eventually get into future classes looking at how the DNA and genetics and all that part. It's just little tiny pieces, but if not arranged correctly, then you can see why the cell doesn't work the way it needs. Now, all of that, everything that we eat, is controlled by what we call our metabolism. Okay, so metabolism, that word is very important. It literally means all of this life-sustaining chemical reactions that we're going to look in details into future videos that is needed by the human body. So the body, when you eat things, or even after you eat those things, it's doing two different processes within metabolisms. Catabolism, think of a cat knocking something off. Okay, it's breaking down. Okay, and that helps to make ATP, energy. And then anabolism is about building things up. Okay, so within metabolism, there are two different parts of it: breaking things down into smaller pieces so the body can reassemble it, or taking those pieces, making them into larger, assembling them together. Okay, that usually one of them makes ATP, the other one uses ATP. So you can kind of see why you need energy to make energy. It's kind of crazy when you think about that. But, you know, there are six different forms of energy. We're going to focus a lot on the chemistry side of it, but we think of mechanical, movement. Okay, that would be a type of energy. Chemicals, what we're going to mostly focus on throughout the weeks. There's electricity, obviously the positive and negative. There's, we think of radiation, thermal, nuclear. Okay, there's a whole list there. Okay, but I want to focus on the chemistry output of ATP into future classes. And I keep saying the word ATP. It's like, what is ATP? You definitely need to know. Okay, so ATP is adenotriphosphate. Okay, triazine triphosphate, I'll get it out here, adenosine triphosphate. ATP is the energy, the name of the energy that our body needs. Okay, and it gets that from glucose. It gets that from sugar. So hopefully within this chapter, you kind of see there's two main areas you really want to focus on, okay? The first one being the different types of elements, ions, minerals, okay? They're all the same thing, electrolytes, again, if they're stuck together. You got to know that. The second part that is vital within this chapter that you need to know is pH, okay? If you get those two down, you're 14 steps ahead, I should say 1,000 steps ahead, but at least 14 steps ahead when it comes to the information from chapter 3 and going forward. Okay, so you definitely want to get those parts down. Well, it's good seeing everyone again in my video. Manny didn't help as much. Oh no, I dropped Manny. Oh, I'm sorry, Manny. I gotta stop and pick up Manny. But manatees are awesome, and Manny has enjoyed working with you today. Make sure you get into your textbooks, looking at it multiple times, and I will see you all in the next video.